But if you like say something embarrassing, I'll crop it out before I share it publicly, but it will be available on Blackboard for the other participants, at least for the next couple of weeks. Uh, just in case you were thinking of, I don't know, showing us your burping rendition of the alphabet or something like that. Which I had a childhood friend who was capable of burping the alphabet, and I thought that was very impressive at the time. I still think it's very impressive. Hello and welcome to session 3 of the R workshop that I've been doing. This is picking up on the portion that I referred to as Unit 2 in the shared document, because we got through about half of that in session 2. And so this is the portion of the code that I shared that starts with data and subset arguments. And if you're following along in the PDF, that's also a heading in the PDF, data and subset arguments. So what I'm going to do is share my screen, and you're going to be able to see R instead of me for most of the time. But please interrupt me if you have questions. So what I've done is I've opened R, and I've pointed it at the working directory that we were working in before with the example data that I shared last time. And this is the same code file that we were working with last time. All I did is I scrolled to the point we were at, which was right here. And I only ran a couple of lines of code to get us set up. Remember last time we read in a data frame, so I reran this line of code that found that tab separated text file and read it in with a header row and called it data1. So that's a data frame, one of the data types that we learned about before. And then I attached that data frame because that's what allows us to refer to variable names within the data frame without reminding R what data frame to look in each time. So then I ran the search function, which, as you recall, should return a vector of kind of like locations where to look for names of objects or functions that you refer to by name. And the only data frame in here is data1, just as it should be. The rest of this stuff is packages that are included as part of the base R installation. So that should allow me to pick up where I left off in the code, so I can refer to variables in that data frame by name. And I'm going to run this line of code first, which just repeats one of the regression models that we talked about last time. So as a quick reminder, the LM function is the output of that function is the first argument to the summary function. And this LM function is the basic linear model function in R. And in this example, I'm only supplying it one argument, a formula specification, this portion of the code. And score is the response variable. The tilde separates the response from the predictor variables. And then the model that I've set up is an age by gender interaction. And the asterisk tells R that I want it to include the interaction between those two variables and the lower order terms necessary to support that interaction. And I plug the whole thing directly into summary so that I can get a nice regression table as output. And that's what I have over here. So this regression model tests the age by gender interaction, and it's, I guess, some people would say marginally significant. I don't necessarily recommend using that language, but just for a reference point, the p-value is 0.075. It's a negative slope associated with that term. So that's all review. What I want to show you now is that the LM function has handy data and subset arguments, and these arguments are present in lots of other statistical functions too. And you'll probably get used to using them a lot because they're quite handy, and they are, if you're not using the attach function regularly, then these are going to be kind of the basis of how you specify what data set you're working with at any given time. And the first step here is I'm going to create a new variable called S that just stores indication of which cases have gender equal to F. So this gender variable has two values. I could type gender at the console. Remember, this is a small data set. So if I type the variable name at the console, it will print the whole variable, but that's okay because it's not a very long vector. just 20 values, and they are M and F. So when I created this new variable, S equals gender double equals F, then it gives me a vector of 20 Boolean values, falses and trues, indicating whether the corresponding gender was F in the data set. And so I have not shown you this yet, the double equals sign, but it's just a way to test equality in R, like in many other programming languages. So double equals, you can think of it as kind of like a function that takes two arguments, one on the left-hand side and one on the right-hand side, the quote F close quote here, and returns a value, which is true or false. Or if one of these is a vector, then it returns a vector of trues and falses of the same length, indicating whether each element of that vector is equal to this value or not. Um, as a quick aside, gender is actually a factor, and so these values in the latter half of the vector are not technically string values F, but R is able to tell that that's what I mean when I test this equivalence, because these 20 values all have the label that is the string value F. So that's good enough for R to say that they're equal, and S then is a vector of 10 falses followed by 10 trues. I'm going to use that vector because that can be used to indicate a subset of the data that I want to work with. So if I use the subset argument within LM to fit this linear model, all I've done is model score on the basis of age. Now I'm not looking at a gender interaction, but instead I'm looking just at the subset defined by the variable S. And I do that by supplying a second argument to the LM function, subset. And I'm assigning that argument the value of this vector that I created that specifies which cases I want to use. The trues are the ones that are going to get used. The result of this is a regression model that provides the slope of the relationship between age and score for the female participants only, which we should already remember from up here. Remember, this regression model looks at the age by gender interaction, but gender M is the indicator variable for gender that got included by default, based on the fact that gender is a factor and R chose its default encoding based on the fact that F comes before M in alphabetical order. So M is 1 and F is 0 in this indicator variable. And because of that, this row represents the slope for age among the female participants, the participants who are coded as 0 on the interacting variable. And that slope is 0.289. And when we fit the model on just the female subset using the subset argument, again, we got 0.289. This is as it should be. It's necessarily equivalent to this simple slope up here. The p-value is not the same. The standard error is not quite the same. That's all also to be expected because this model is fit on a smaller subset of the data, and so has less information to go on when determining the error bounds on the estimate and the typical amount of noise. So the subset argument works like that. Remember that I was able to refer to score and age by name because data 1 is attached. So I'm just going to detach it now to show you this next piece. So here I'm going to fit this score modeled on the basis of age and gender and their interaction regression model again. But this time I'm going to use the data argument. So here I specified the exact same formula that I wanted to above, but data 1 is not attached. So these variables, if I refer to them by name now, like I type age at the console, it will tell me object not found. Because there's no object in the global environment and R doesn't know where to look to find an object that has that name. But the LM function can take this data argument, and I specified data 1 is the data frame I want it to work with. And so that works just as well as having data 1 attached, and is often more convenient if you are running models on multiple data sets in the same session, or you're planning to switch from one to another or deal with a bunch of different subsets or something like that. So this output should be exactly the same as when I got the age by gender interaction above, and it is, and the simple effect for age among women is still 0.289. And I can use these arguments together. So here's a version that looks at score on the basis of age alone, just for the women using the subset argument, and the data argument at the same time, and I get the same single predictor regression model that I had above when I used the subset argument without the data argument. And so putting all of this together, I will often do things like this. I didn't want to jump straight to this in case it would be confusing, but this line of code just looks for the summary of a regression model of score on the basis of age. This is the model specification. I'm going to look in this data frame for these two variables, data one, and I'm going to only look at a subset of the cases in that data frame. And that subset is defined by this vector. So sometimes I might skip the step of storing a vector that indicates which cases I want to use, and instead just put the computation for that vector directly in the function call. So gender double equals f will still return a vector of trues and falses. I put it in parentheses partially just because it makes the code easier to read, in my opinion, that it's clear that this entire parenthetical statement is the value being assigned to this argument for this function call. But that might be a matter of personal preference. So let's say you wanted to use the log of age as a predictor in your model instead of just age. You could calculate a whole new variable called log age. That's the log of age, and then include that in your model. But you can also do it on the fly by running a line of code like this. So it's perfectly fine to do score tilde log of age. So you can put function calls in your formula specification, no problem. And here we have a model that has log of age as the only predictor of score. Sometimes you will want to use this I function in order to do that. And I encourage you to use it if you're not sure whether you need to use it, because it won't do any harm if it was not necessary. This I function is, I think of it as the identity function. I don't actually know what I stands for, but it tells R that you want the contents, the argument to that function, to be interpreted literally as a mathematical operation and not as part of your formula specification. So you need to use I if there are characters in the math that you're trying to do that would be interpreted as special formula characters otherwise. And so some obvious ones are the asterisk and the plus sign that you already know about. Like asterisk means include the interaction term and all of the lower order terms. But if you actually just wanted two things multiplied together, for whatever reason, then you could include them. Well, you could use the colon, which we already know is one way to do that, but you could also use I and then use asterisk as the multiplication sign between them. It turns out that the caret symbol is also a special character in formula specifications that I just haven't taught about in this workshop yet, a very handy one that I'll talk about later if you want me to. But in order to tell R that I really want age squared and I'm not trying to use the caret as a special character, I've just enclosed age squared in this I function call, and then I get the model that I asked for with age and age squared as predictors of score. So a linear term and a quadratic term here.